You are here because you want to understand how to accelerate your Kubernetes journey with Amazon EKS. You may just be getting started out on your Kubernetes journey. You may already be using Kubernetes, but want to understand how to move to EKS and the benefits of doing so. Or you may be an existing Amazon EKS customer and you want to understand how you can optimize your deployment. Today we'll go through a variety of topics that will hopefully address all of those use cases. My name is Ollie Pomeroy, and I'm a Senior Developer Advocate here at AWS. Later on in the talk, I'll be joined by Grace, and Grace is an EKS SME. And then I'll hand over to David. And David is from Sportradar, and he'll talk to you about Sportradar's journey of migrating from self-hosted Kubernetes to Amazon EKS, and really show some of the benefits they saw by doing so. But just before we get started, I just want to do a quick raise hand survey. Who here is actually using Kubernetes today? Okay, quite good, just about half of you. And then out of those, who is using Amazon EKS? All right, then probably about a third of that. Okay, it's good to know. That helps me understand who I'm talking to. So, for those getting started out on your Kubernetes journey, you'll be coming at this from a variety of different ways. The first of which is because you're looking at a way to standardize your application estate. You may be developing new applications as microservices. You may be lifting and shifting applications from the cloud, from on-premise to the cloud. You may be wanting to standardize your application estate across a wide variety of different use cases. Stateful applications, stateless applications, data processing, batch, machine learning, maybe even some new Gen AI applications. You want to try and find a way to standardize your deployment. And by using containers and by using Kubernetes, you're able to do so. Once you package up your application into a container image, you can then use Kubernetes to deploy it the same way, monitor it and scale it. You don't have to use different tool sets regardless of what your application architecture looks like. And then by using Kubernetes, you're able to reduce the time taken to roll out new releases and deploy new software. Other people out there might be using Kubernetes because they have high scale requirements. Maybe their applications need to be very reactive, high peaks and troughs in their traffic. Or maybe because they're trying to build a single platform to support a wide variety of different workloads and they need a platform that can scale. And then finally, people come to Kubernetes because they want to take advantage of that open source extensible ecosystem. There's lots of partners and open source tools out there that you're able to use once you move your workloads onto Kubernetes. But you have all told us that managing Kubernetes is hard. Once you decide to build a platform on Kubernetes, you then have a bit of an operational overhead or a burden to manage. First, there's a significant investment in actually managing and upskilling your staff to run a Kubernetes platform. There are mission-critical components that you have to feed and water. You have to worry about how you're going to scale them. You're going to have to worry about how you're going to upgrade them. And this is an operational burden that you didn't have to manage before, but you do now that you've chosen to build on Kubernetes. Secondly, you have a whole new attack vector that you need to understand and secure. You may be familiar with your on-premise estate. You may be familiar with AWS landing zones. You've now got a new Kubernetes API that you want to understand, secure, and lock down. And then finally, workloads that run on Kubernetes aren't normally running in isolation. There are parts of your estate that are not containerized. Maybe it's your persistent data running on an RDS, or your storage living in Amazon S3. And there's a level of complexity around how your workloads that are running on Kubernetes can talk to these external parts of your architecture. And all of these, operational overheads, we here at AWS class as undifferentiated heavy lifting. These are things that we can do to make it easier for you to manage and run your applications. Just to visualize a Kubernetes platform in a little bit more detail, once you've decided to build on Kubernetes, what you actually have done is you've now given yourself lots more decisions to make and operational components to run and secure. For example, what computer are you going to choose? How are you going to scale it? Are you going to bring in new monitoring and observability tools, or are you going to use your existing and use their Kubernetes integrations? Are you going to expose Kubernetes to your developers, or are you going to bring in an IDE or a development platform and kind of mass Kubernetes from your end users? And really, these are all decision points that you need to think about on your Kubernetes journey, and they can really kind of slow you down as you go on this journey. Now, that brings us nicely onto Amazon EKS. And for those of you that weren't using Amazon EKS at the beginning or are new to the topic, Amazon EKS is a managed service by AWS. And with Amazon EKS, we take care of managing, securing, scaling, upgrading the Kubernetes control plane. That is the managed service element. You have a Kubernetes API that you can use to deploy your workloads. And then behind the scenes, we have opinionated ways to complete the rest of your platform, or through various integrations and work we do with our partners and ISVs, you can then complete the rest of your Kubernetes architecture. To tell you more about Amazon EKS, I'm now going to hand over to Grace, who's going to dive in to the EKS control plane.
Thanks, Ollie. When we think about Kubernetes clusters, we can sort of logically separate it into two parts, the control plane and the data plane. I want to start with the control plane. For those who aren't working with Kubernetes today, understanding what it is, what customer challenges people are facing, and how EKS can help alleviate those. So the control plane is responsible for running the cluster. It deals with things like scheduling and orchestrating the nodes, responding to events and sending instructions to your worker nodes. It's also where the etcd database is found. This is that key value store that stores all of the vital information to maintain the desired state of your cluster. It's a really important component, and ensuring that the performance of the control plane scales in needs with your cluster is really, really key. And these are some of the pain points that you've talked to us about. We're going to talk a lot about scaling today. It's across both the control plane and the data plane. As the cluster activity grows, the control plane needs to scale in line with that to support this. But making sure this is done in a timely way, securely and with minimal downtime can present challenges. It can result in operational overhead, poor performance when scaling is slow, and also overcautious scaling that can lead to unused capacity and unnecessary cost. So how does EKS work and help with this? As a managed service, the control plane is then a managed control plane. And what this means is as you scale your pods and nodes, it will scale vertically to meet your demand, but it also will scale back down. The control plane is highly available, deployed across multiple availability zones, and this means it can withstand single availability zone events. There are at least 2 copies of the API server across 2 availability zones, and 3 copies of the etcd database across 3 availability zones in an AWS managed account. Being a managed service, it means that you also get AWS support with your EKS clusters. Now, we use a number of different metrics to determine how to control the scaling, as you'd imagine, CPU and memory, but also the sizes and the numbers of your clusters and the size of your etcd database. It's also important to note that we only scale down your control plane once utilization has dropped below the threshold and stayed there for several days. Updates, we love them. Customers have told us that keeping up with the cadence of the Kubernetes release cycle is quite a challenge. We're committed to supporting 4 production-ready versions, with each one being given 14 months of support. It's important to note we don't allow alpha feature flags. We want to make sure the version that you're using is stable in production. To make it simple, upgrades in EKS are just a single action. But actually, the next challenge comes from understanding the readiness of a control plane for an upgrade. For those who know the pain of having to research and identify any changes coming in the next upgrade, understand that is there deprecated Kubernetes APIs, and then what remedies do you need to do? And so listening to your feedback, the Kubernetes team got to work, the EKS team, got to work and brought a new tool in 2023. Cluster Insights provides recommendations back to you ahead of your next upgrade. It includes links to the docs and links to the blog posts. Is anybody using Cluster Insights already? Is it something that people have started to use? Not nearly enough of you, but we've got a few hands. So absolutely, Dave's going to talk a little bit about how they're using it as well later on. What it does is it scans the cluster audit logs, looks for any deprecated APIs, and then brings you back recommendations of how to change it. It does this in the console, but for those who prefer to do it programmatically, you also can use the EKS API or the command line interface to retrieve this information. And really importantly, you can reduce time researching and start working through those recommendations ahead of the next cluster upgrade. Now, we'd really prefer for you to upgrade before those 14 months are up, but sometimes unavoidable things happen. And so we introduced extended support last year. This provides an additional 12 months of support on top of the 14 months already offered. It's worth noting that it's a paid-for service, so if you can, please try and make use of the tools we've made available to get that upgrade done in a timely fashion, but know that there is that safety net that you can lean into should you need it. Authentication and authorization is a pain point for many, many customers. EKS has been integrated with Identity and Access Manager, or IAM, for a number of years. However, customers have told us that using two sets of APIs, trying to map your Kubernetes objects against your Identity and Access Management resources has been a challenge. And so the introduction of IAM Cluster Access Manager has simplified this down to just a single API. Another great thing about this is that actually providing access to AWS services, you can also use the same tool. Many of our customers are using things like Amazon EMR or AWS Batch, and being able to do this in a simplified way is something that we hope that you'll all benefit from. Security is a top priority at AWS, and we know that it is for you too. And so as a managed service, we already apply security patching to your EKS control plane, and we encrypt your etcd database. But further to that, we also integrate with core AWS security services like Amazon GuardDuty, which is our managed threat detection service. Combining the logs from CloudTrail and the Kubernetes audit trail logs, you can detect potentially suspicious activity within your cluster. We know that getting insights as well into what your containers is doing is something that we've had a struggle with in the industry for many years. And so the introduction of EKS runtime monitoring provides on-host operating system level behavior, and this includes things like file access and process execution and connections on a networking level. Now, key to this, it's great to know that there's a security risk, but identifying exactly what pod and container that is coming from has always been a challenge. And so as well as providing the insight, you're also given the specific container information. You get the pod ID, the image ID, and EKS cluster tags. Hopefully this will keep your security teams happy too, because not only are we providing the mechanisms to authenticate securely, we're also providing all of the auditing that you need, not just for authentication, but how your pods and your containers are actually behaving. So let's dive into the data plane. For those who are still new to Kubernetes, this is where you run your workloads. It really is just a collection of EC2 nodes that EKS uses when it's deploying your workloads. For some of our customers, the number of EC2 instances in use can run into the hundreds and sometimes even the thousands. So this is a mammoth task in scaling and keeping on top of that data plane. The challenges you've told us about, of course, scaling, also really reducing the operational overhead of keeping AMI drift in check, making sure that you're running the upgrades in time, ensuring that nodes are replaced and that everything is run as it should be. And also, as we're seeing more diverse workloads come into the cloud, ensuring that you have access to things like Spot instances and Graviton instances that really lean into some of that cost optimization is something that you say you haven't been able to really access. So we've offered a few ways over the years to do this. We started with self-managed nodes. Now, for anyone who had the painful job of doing this in the early days, you know that what this means is effectively it's your job to deal with the nodes. We're able to provide some element of isolation, but you still have to run all of the upgrades. You have to keep on top of all of that. And actually, the provisioning and the scaling and the handling of upgrades was a challenge. And so we moved to EKS managed node groups. This did help deal with a lot of those issues, but still left us with some node sprawl issues. I'm going to talk about that in a second. And so also a final option for those who want a fully serverless offering, we have Fargate. So let's look at the node sprawl issue that I talked about. This may be something that people in the room are very familiar with already. We've got a team. We've got a few different workload environments, maybe the back-end team, maybe the front-end team, and each of them has a managed node group. And that's fine. But let's say we onboard a new team, the ML team. We'll all probably guess that the nodes that they're going to use are probably going to be quite different in terms of the compute resources. So we create a new node group, that makes logical sense. And then we bring another team in, and they need a different type of node group. But what ends up happening if something that should be deployed into the machine learning node group would actually be better served by a node that sits in a different node group? The reality is that you either then have to break with the protocol of using the managed node group assigned to that particular team or that particular product or business function, or you end up having to create another managed node group that points to other types of instances, and this gets really big as it scales. What we end up having is a real lack of diversity of nodes at a node group level and a huge amount of node sprawl and underutilization, as nodes could be sitting with minor amounts of workloads on, but other teams can't make use of them. And so the EKS service team created Carpenter. Carpenter handles the provisioning and the scaling and removes the need to have multiple node groups, and all the manual operational overhead that comes with that is then lifted. So how it does this is it chooses the most optimal node based on your pod specification. You just write what your container needs, what your pod is going to need to run that workload, and Carpenter then leans into that deep integration with Amazon EC2 and chooses the appropriate node. It also can lead into those cost savings by using things like spot instances, making use of Graviton, and it removes that underutilized capacity that's sitting across your various node groups. But it isn't just about cost, it's also about speed. You're going to hear from David shortly about the impressive results achieved in speed of scaling through the use of Carpenter. For those less familiar, just from a visual perspective, you may be familiar with this way of doing it, where you want to deploy your pod. If you're not using Carpenter, you'll use the cluster autoscaler. That will kick in and send instructions to the designated autoscaling groups. The autoscaling group will check if there is a node with capacity. If it is, great, it deploys the workload. If there's not, then it will create a new node. It's not aware of Kubernetes, and so it's only able to either add or remove nodes. It can't make intelligent decisions like things like bin packing. That's not what it's designed to do. Carpenter then replaces these two processes. And so rather than having the autoscaler speak to the cluster autoscaler speak to the autoscaling groups, Carpenter does the work. You just define the resources your pod needs, and it then also maximizes those nodes by packing nodes on, and it will move workloads and consolidate your pods as the demand changes to make sure you don't have that underutilized capacity. It does a little bit more than this as well. It also provides, it fails back from on-demand to Spot, which is something that I know sometimes can be a blocker for people wanting to use Spot, but it's able to make those decisions for you. It also deals with drift detection and AMI images. I know David's going to talk about that a little bit more in a moment. And it also provides that for customers that have those really high spiky demand workloads, or a diverse set of compute nodes that they need to work with, you can move away from having loads of managed node groups and you can move to Carpenter. Now I'm going to hand over to David, who's hopefully really going to bring to life how they've actually used this in a real world scenario. And for those already using Kubernetes and EKS, I think you're going to learn some great lessons from the journey that SportRadar have been on. So I'll hand over to David now.
Thank you, Grace. I'm really excited to talk about our own journey to Amazon EKS, how it helped us accelerate our development process, and I want to touch on a few challenges we faced along the way as well. But first, let's start with some mandatory introductions just to help you paint a picture. So Sportradar is currently the world's leading sports technology company, right at the intersection between sports, media, and betting. And we're positioned right between all of the major sports leagues on one side and betting operators and media companies on the other. Instances or running Kubernetes workloads across 100 different clusters. And of course, over time, different challenges started to surface. We had a huge configuration drift in both Kubernetes versions and of course all of the different tooling our product teams were adopting on their own, which of course, you know, it's hard to provide ownership and support those components that are just being adopted all around the place. And bundle that with our complex and diverse workloads, so everything from applications just being thrown inside containers to complicated stateful sets, memory distributed applications across multiple nodes. It's quite obvious that something needed to change if we wanted to keep our business growing. So last year we partnered up with AWS and we started building our new Kubernetes platform based on Amazon EKS. And we've set ourselves with 4 core design tenets that we wanted our platform to follow. So we wanted it to be centrally managed, completely automated, secure, naturally, and of course scalable. Ultimately, we wanted to keep enabling our product teams with the autonomy through a standardized and productized platform. But let's start at the beginning. So our problems were not all technological. So our first steps were actually organizational changes. We needed to grow our team and we needed to stop thinking about our platform as a framework, but more as a proper product, right? So we put on our product-centric hats. We started centralizing all of the different knowledge about all of the components in a centralized team. And this was really the first step if we wanted to offer support for all of the infrastructure and of course critical KATES components like core DNS, cert manager, and things like that. But a really important aspect for us was also to build and to nurture a strong internal community around the product. We're building the platform for our end users to make developers' lives easier. So it's really important to have our community engaged in all of the stages of the development lifecycle. And it's quite evident from our initial goals that if we wanted to achieve that, we need a strong automation to back us up. And we really do believe automation is key in every product you're going to develop. And you should design your products hand in hand with automation in mind. And this is actually one of the first challenges we faced when adopting Amazon EKS. So we started off with EKS Blueprints module v4, and after a couple of iterations, it turned out at least for our complex clusters, it was quite a big, complex monolith. And it was really hard to debug different failures in Helm deployments, or maybe even in applying Terraform infrastructure. So it actually started to increase our total cost of ownership, which is exactly the opposite of what we were trying to do. So we took a step back and we thought, you know, we don't need a space shuttle to run our platform. So we designed a much more rudimentary pipeline with 3 basic components. So we kept using Terraform to provision and to manage our AWS infrastructure. And of course, we leaned on the upstream EKS module to help us out there. We kept using Helm to manage the core add-ons and components in the cluster. And of course, a strong CI/CD pipeline just to validate all the incoming changes to our repositories, to run the diffs for us, and to bind all of this together. And we intentionally and strategically positioned, with automation, positioned our platform right between self-orchestration and self-service. And the main reason we still wanted to be involved in this process is, you can imagine, a regulatory compliance. So it's, as part of our business is focused around sports betting. And as we became a public company a couple of years ago, our compliance checklist just keeps growing. And we are under a lot of regulatory compliance from authorities around all the world. And with Amazon EKS, you can immediately tick a few boxes. So all of your Kubernetes audit logs and control plane logs will be shipped to CloudWatch. You can use CloudTrail to audit all actions against the actual EKS cluster through AWS API. And a really helpful feature for us was that, enabled by default, EKS will automatically rotate your cluster certificate authority, which just helps you invalidate any long-living tokens you might have in your cluster. But as we're running a lot of sensitive workloads, we didn't stop just there. So we were constantly thinking about the whole Kubernetes security posture. And we strongly believe you should always design your own systems so it's easy to operate and deploy your applications securely right from the beginning. And I want to focus on 4 key aspects of our security posture. So Grace already talked about how Amazon EKS integrates with IAM, and you can take this even a step further by leveraging what is now called AWS Identity Center. You can manage and govern all access to your EKS clusters using your own identity provider. And bundle that with IAM roles for service accounts, your pods can also natively assume IAM roles to access services outside of the cluster, like RDS, DynamoDB, AWS Batch, and all of the good stuff that AWS can offer. But you can take it even a step further. So by using IRSA together with AWS STS, you can seamlessly integrate with external services as well. And this just helps you mitigate and limit any potential blast radius if, or a better word, when your secrets eventually get leaked. So, even without putting in much effort, we have already checked a lot of boxes on our checklist. And the next topic I want to touch is pod and network security. So based on the initial ask from Ollie, a lot of you here are already familiar with Kubernetes, and pod security standards are really a basic Kubernetes construct that just helps you limit the capabilities of your workloads. And this helps in reducing some common attack surfaces like privilege escalation. But this was a challenge for us because EKS defaulted to using a privilege profile from the beginning. And since security standards are a control plane concern, there's really no way for you to configure the defaults there. But we scanned the CNCF landscape and decided to adopt a dedicated policy engine for that, which just helps us automatically annotate any new namespaces with a baseline profile. On the other hand, networking was a major change for us. So we went from having an overlay network, which we controlled, to using VPC CNI. And at the time when we were building our new platform, VPC CNI was really missing one critical piece of functionality, and that's support for Kubernetes network policies. But again, it sounded like a blocker for us, but we thought about it and it just hit us. We already have the experience and we already have the solution at our fingertips. So we decided to continue using Cilium, but we chained it as a secondary CNI and use it only as a network policy engine. And Cilium will provide you with great functionality and powerful network policies. And of course, you get an awesome bonus side effect. So it will increase the visibility into your network. With a tool like Hubble, you can see exactly how the network is flowing inside your cluster. And the last topic I wanted to touch on security is runtime security. Grace did a nice introduction to guard duty, and the recently released runtime security for EKS But what I want to add to this is just how simple it is to install and to operate this in your own clusters. It's a managed EKS add-on, so it requires just a few simple clicks in AWS console or maybe a few lines of code in your ISC repositories. So our clusters are automated, they're secure, but I want to talk about one last important aspect, and that's scalability. So we operate a lot of clusters and we really observe a lot of different usage patterns. So some of our clusters are pretty static, like the green one on this graph, but others breathe organically. So they will scale out, scale in, you know, a lot's happening there. And imagine a big game like a Premier League finals, right? We know that we're gonna get higher traffic. We preemptively scale out our infrastructure. It's all going well. But in those last 10 minutes of the game, we just get a flood of inbound requests. And we don't want to start dropping traffic or failing those. So not just scaling, but what was important for us was to achieve a rapid scale-out time. And we set our goals in under 60 seconds. So we wanted from a scale-out event to when a node is ready and a pod is already deployed there serving traffic, that this time window be less than 60 seconds. Of course, self-managed node groups were out of the question, and our initial baseline test was using managed node groups with Cluster Autoscaler. We ran a simple scaling test a couple of times, and we came in just over 3 minutes. So it was, you know, not that bad for probably most of you, but for us it was a real deal breaker. But we got wind of a fancy, cool new autoscaler that Grace introduced, and that's Carpenter. We love Carpenter so far. It's AWS aware, it's Kubernetes aware, but what we love the most is that it lets you manage your node specifications in a more Kubernetes native way through custom resources. So we kept Ubuntu as our base AMI, we just switched the autoscaler, replaced it with Carpenter, and we ran another scaling test. And the results were quite promising. So we managed to drop down our scale-out time to a little over 2 minutes. And that's a huge improvement by just replacing a single tool. But still, it was not hitting our targets, and we knew we could be much better. So we analyzed the problem, we did a lot of timings, a lot of tests. We even, you know, tweaked the way how we bootstrap and initialize our OS on the nodes. But we finally honed down the actual bottleneck was what we call our image hydration time. So the time it takes for you to boot up a AMI, for it to configure all the K8s components and join the cluster, start serving traffic. You know, we made a couple of tweaks here and there. There were some minor changes in our scale-out time, but not really the results we were looking for. So there was not really that much left for us to do except replace the underlying operating system. And guess what? These are containers, right? We should be able to do that. So we looked at Amazon Linux, but we soon discovered something even better, and that's AWS BottleRocket. It's a purposely built Linux operating system for running container workloads, and as it's CIS hardened, it will bring you an awesome side effect, again, of increased security posture. It only installs the tools that are needed to run Kubernetes components. Of course, the important key piece of information here is that these AMIs are cached locally in every AWS region and every availability zone. So, yeah, we replaced our base AMI, kept Carpenter, we ran our scaling test. And the results were weird. So we ran our scaling test again and again, and it turns out we actually did achieve our target goals. So by making two fairly simple changes, our scale-out time dropped in just under 60 seconds, which was awesome. And we're confident we can push this time even further down, but unfortunately that's not the scope of this talk today. So yeah, those were the 4 core design tenets I wanted to talk about today. But I wanted to touch on another topic that's something we engineers usually dread, right? And those are upgrades. And we do strongly believe that all upgrades should be easy, they should be fast, automated, and you should be fearless when executing them. So if we take all that I've talked about today, Carpenter really shines here. So with upgrades, either be it node upgrades or Kubernetes upgrades, Carpenter will run the whole show. So you define your AMI family in your node spec, and Carpenter's drift detection will make sure when a new image gets published, it will replace your nodes with an updated image, so you are always patched. But be careful, do use node disruption budgets, so you can control when and how fast your nodes can be replaced. And bundle that with a simple setting like node expiry, you can ensure that your nodes are refreshed at regular intervals, just keeping up with all the security patches that are coming on the operating system. Kubernetes upgrades, Grace mentioned the new EKS upgrade insights. They should be your new best friend. They really help bring visibility in all of the upcoming removals and deprecations, and they can really help you prepare your product teams up front. But in essence, the process is exactly the same as with node upgrades. Carpenter will take care of everything. The only key difference is you need to upgrade your EKS control plane, and then Carpenter will pick up on the change and will slowly start replacing all of your nodes with the correct AMI, which contains the correct upgraded Kubernetes version. I talked about a lot of technical things today, some benefits, some challenges we faced on our journey, but I think it's only fair to show the business value a platform like this can bring you. So for us, a big win was we observed a 300% increase in our community engagement. So that's either people attending our regular guild meetings about any new features that are coming up, as well as contributions to our core platform. And those contributions don't necessarily need to be only technical contributions, right? Features and code. They can contribute during the design phase. Your end users can contribute ideas as well. They can drive your backlog and help you with the documentation, all the good stuff here. So really proud we were able to engage our engineers much more. With automation and Carpenter, our provisioning time was improved by 63%. So it dropped to just under 1 hour. And the interesting part here is our process is so optimized, most of the time is actually spent waiting on the EKS control plane to boot up and to be provisioned, which is awesome. But even more impressive is our upgrade time. Our upgrade times were reduced by a whopping 92%. So what took us before maybe 6 to 8 months, which is a long time, right, is now something we can do in a matter of days or weeks, which is awesome. And with all the security things bundled with automation, we achieved 100% automated access governance, which just helps us run through our compliance checklists more naturally. So the value EKS brought to us is evident and extremely valuable. And I just want to wrap this talk with some words of wisdom. Me being an engineer myself, right, we all know that managed services are not always perfect or ideal, but it's what you do with them that makes the real difference. It's how you use them and how you build around them that can make a service really shine. Always double down on automation. Almost every slide I talked about today involves some part of automation, and it will really help you move faster, and it will decrease your total cost of ownership over time. And the most important takeaway, at least from my side, always engage with your end users early on and keep them engaged throughout the whole development life cycle. Maintain a customer-centric relationships. They're the one whose problems you're trying to solve. Thank you all, and now I'm handing over to Ollie to wrap this talk up.
Awesome. That's a a really good, nice story there from Sportradar. And if you think about this talk was all around how you can accelerate your Kubernetes journey with Amazon EKS. And just taking some of those data points that David said, I wanted to repeat those because they were just really, really impressive. You know, he's saying 90 seconds now for them to scale out nodes to ready to run pods. A reduction in 63%. You know, the time it takes them to handle Kubernetes upgrades, an often dreaded part of the life cycle of managing Kubernetes, they're able to reduce by 92%. And as a company that's quite heavily audited, they've automated 100% of their security procedures to meet a lot of those compliance and regulations. That really does embody what we were trying to get across in today's talk, how you can accelerate your Kubernetes journey. And hopefully through Grace's section as well there, you learned some of the key components of the platform. We talked about Carpenter managing your data plane. We talked about GuardDuty, both auditing your control plane logs and also providing on-node runtime protection. We've touched on some of the networking concepts, how we can secure that both with the VPC CNI and then by extending it with some of our ISV partners. Now, to learn more about Amazon EKS, I recommend going to our skill builders. There we have hundreds and thousands of online courses, including some on Kubernetes. You can read some of our ramp-up guides, as well as going and achieving an Amazon EKS digital badge to show off to your friends on LinkedIn. If you head to skillbuilder.aws today, you will also get a free trial to access those Kubernetes resources. With that, thank you very much. Please fill out the online survey that should be in your application, and we'll be hanging around at the back of the room for questions. Thank you.